Okay, guys, let us see our final, in fact, this is not our final question, but we're just gonna consider this for now, because we have got other topics also to consider, but I think we have got covered. No, there's still another question left, so I'll see that one later on. But for now, let's see what we have. 4.1, define energy. We talked about energy as the ability to do work. Remember, power is the rate of change of what work done. But the energy now is that ability to do the work. So this one is the ability. That's the ability here to do work. Just like that. You're done. 1 mark for that. It's enough. Okay. Then on 4.2, we just want to understand this. There is a load of 4,000 Newton, right? And is lifted to a height of 30 meters. Right, so the load there is 4,000, and by now you now understand me when I'm saying the load. All right, first days maybe it was not making sense, but now it makes sense. So there we have got the load, and the force there of this load is given as what? This is the force of the load, 4,000. So there we have got 4,000 Newton. All right, 4,000 Newton. It is lifted to a height of 30 meters. So this is the distance. So we've got the distance, 30 meters. What else? Then also here they are saying by means of a chain. So we are using a chain that is wound on the drum at the top. The chain has got a weight of 20 Newton per meter. So there we have got the weight of the chain per meter. All right. So the first part was the load. Now we've got the chain. And for the chain, we are not given the actual weight of the chain. No, we are given the weight of the chain per meter, 20 Newton per meter, 20 Newton per meter. So what is going to be the total weight of the chain? So the total weight of the chain, like I said, is the weight of the chain per meter times, because this is in Newton per meter, so you have to multiply by the distance in meters, all right? So you multiply to the distance in meters, which is 30. So this was going to give you 600, all right? So this is going to give us 600 Newton, okay? So this is not the question. The question is make a neat sketch, all right? So that is our question. Make a neat sketch of the load distance graph. So the load distance is load, it's force, load, it's force. So they are simply talking about what? Force distance graph. That is the load distance. Using the above information determined by making what, all right? So this is from what? From the information that we have here. We are supposed to have the diagram. Like I said, guys, the diagram, we simply need the force on the vertical axis and the distance on the horizontal. So we are going to have something of this nature. That's the force on the vertical. Then the horizontal, we are going to have the distance. So here we are going to have the force in Newton, and these values, it's like we worked these similar values as they are. All right, anyways, on your distance, the distance is the most important because it's a 30. So maybe this is 0 here, this is 10, this is 20, this is 30. So at 30, it must correspond with the force, which is the weight of the load. So at the first point, you have the load, and the load is at 4,000 Newton. That is where we have the load. The load is the one that is what? 4,000 Newton. So the load is at 4,000 Newton. I said the first point is the load. All right, this one. That is where the load is located at this point. This is the load. Then from A, we go to B, where we consider first moving through this whole part here that we are taking from A up to B. All right, I want this one. From A up to B, there's this distance that you see here, this one, the difference that we see here, is the weight of the chain. This is the chain. So this is the weight of the chain, which is 600. So that's where we have the 600 Newton here. So meaning to say at point B, at the end point there, where we have got our point B here, that's the end point, which is the total weight. So the total weight is going to be 4,000 plus 600, which is at what? At 4,600 Newton. So this will be at 4,600 Newton. So take note, we could have even calculated this force at B, which is the weight at B. I said there's a formula there. It states that it is the force of the load, which is the force at A, plus the force, which is the weight of the chain. So is the force at A, which is the force of the load, plus the force of the chain. So you simply have to add these two, the force at A and that at of what? Of the chain. So if we add the force of the load is 4,000 plus 600, we get 4,600. It's one and the same. So taking A straight to 30, because A is going to be taken straight to 30, straight direct until you meet 30. This one, you draw it straight until you meet 30. So the last one, you just have to join at 4,600. You just, because you have got a ruler there, you're just joining with your ruler from this point up to the what? Up to the end point here. Oh, sorry for that. Sorry, like this. Up to the end point, you're just using your ruler to join that. All right. That's how you draw your force distance there graph, provided that there is what? A force per meter. That is how your diagram is going to be. If it is projected vertically up like this, it's going to be a rectangle and it is just going up like that. All right. But this one, there's a force per meter, meaning to say the force is changing per unit what? Length. At a certain meter, at 1 meter, the force is 20. At 2 meters, the force is changing. The force is changing at the weight. So at 30 meters, it is going to be 20 times 30, which is going to be what? 600. It is changing per meter, but the force is given this side. You don't see it this way, okay? That is the idea there. So that's your diagram. So this is the part of what? Of the chain. This is the part of what? Of the load. So this is the force of the load. This is the force of the chain and the total force at the end, which is the total weight, okay? So that's how your question might be given as. Then from here, they want us to determine by making use of the graph now, which is the one that we drew in 4.21, to calculate, to determine the total weight of the chain. Right, already, guys, we have got the total weight, so there's no need was here. But from the diagram, if there was this one, it was from the calculation. So from the diagram, because they are saying from the diagram. So from the diagram, how do you calculate the total weight of the chain? You subtract, isn't it? So that's 4.22. The weight of the chain, which is the force of the chain, is simply the difference between these two. That is the force at B minus the force at A. So the force at B, it's 4,600 minus the force at A, which is 4,000 like this. So you subtract, you're going to obtain 600 Newton, which is the same as this one that we obtained by calculation, not from the diagram. This one, it was from calculation, Newton per meter times that number of meters that we are given, the total number of meters. That was the idea. All right. So that was it here. 4.23, the work done, take note, the work done in winding the full length, we need to talk about the total length with the load attached to the bottom of the chain onto the drum. So this is the total work done. So when using the full length and using the full, the total length of the rope also to consider. So you consider this as the total work done, which I said is the work done. That's 4.23. So I said this is the work done considered as the work done of the load plus the work done of what? Of the chain. I talked about this, guys, if you still remember. So the work done of the load, remember this is the load here, is the area of the rectangle. Length times width, 4,000, which is our side, this side, times this side. This is our rectangle. Simply multiply, or 30 times 4,000, or 4,000 times 30 is one and the same thing. Area of a rectangle plus the chain. The work done of the chain here. This is the chain. What we have is a rectangle. It forms a rectangle. So a rectangle, that's a triangle. It forms a triangle. So we are going to calculate the area down the shape, which is a triangle. That's a right angle triangle, half base times perpendicular height. So it is going to be half. Okay, let's save it here. So this is going to be half of the base from this point up to this point. That's 30. So this is half of what? 30 times the height, which is the wall of this line here, which is 600. So that is going to be 600, which is that is the weight of the chain. The work done of the chain, work done by the chain. So the work done by the load, work done by the chain, together combined gives us the total work done, and that was going to be 129,000 joules, which is 129 kilojoules if we divide by 1,000. So that is it from our calculations, of which we could have just calculated from the trapezium concept, because we understand that the total work done is simply the area under the graph. So if it is like that, that the total work done is area under the graph, what about the shape that we see under the graph? What is it? This shape here. It's a trapezium. And the work done is equal to the total area under the graph. All right. So if it is like that, it is equal to the total area under the graph. So what does it mean? It means we are simply considering the whole shape at once. The area of a trapezium, half sum of the parallel sides times the perpendicular height. So these are the sides that are parallel, this side and this side. They are parallel to these two sides. They will never meet. All right. And this is our perpendicular height, the one that meets at what? At 90 degrees. So we're going to have half of what? Those sides that are parallel. So this is going to be half of the sum. We are adding these two. The wall of this side, which is 4,600. The length of this is at 4,600. And this one is at 4,000. This side is at 4,000. So it's half of 4,600 plus 4,000. 4,600 plus 4,000 times the perpendicular, which is the difference, which is the distance there from 0 to 30. That is 30. That is how we could have calculated this, okay? So we've got the total work done there. And that was going to give us 129,000 joules, which is 129 kilojoules, like I said, if we are to divide by 1,000. All right. We do not going to waste much time. I want us to understand this one. Yeah, this is very, very important here. They are saying 4.24. Please, guys, be with me just for once on this one, because I want to clear this in mind and we understand this forever. The power, all right, take note, the power applied when the load, when the end of the chain with the load is 15 meters from the drum. All right, 15 meters. I talked about this when I was saying we have to consider the distance, the top distance. If you still remember, you calculate the total force times velocity, but that force of the chain, you consider the total, the top distance. If you still remember, I think that was the first or second revision. But here, if we consider this, I want us to be, they are saying 15 meters. I just want us to be clear about this. It's just a special type of a question. It's what? 15 meters. And if we consider this 15 meters to say it's the bottom line 15, and we subtract to find the top distance, this is what was going to happen here. Let me reduce here. Okay, let me reduce up to here. This was going to happen. 15 meters is here. And if we subtract 30 minus 15, what do we get? We get also 15, meaning to say 15 is the midpoint, because there's 15 here. There is also 15 here. So it's a special type of a question when it is like this. There's 15, there's 15. So the force that you are going to be talking about that you need there is called the average force. Remember, okay, let me remove this. Remember, we are supposed to calculate power, and we've got what? We are given velocity there. Given velocity, the formula for power that we are supposed to use in this case is supposed to be given as what? The total force times the velocity. But this force that we are talking about is no longer the total, like it is the same as that one that we used to calculate, but it is taken at halfway because it is at 15 meters. And at 15 meters, we are considering at this point, which is halfway from 30. So 15 meters is what? It's halfway from what? From 30 meters. So if it is at half, this F is called the average force. You use the average force. Whenever it is at what? Whenever it is at the midpoint, you use the average force, where the average force is simply the sum. Remember, average, guys, is you add two things, then you divide by 2. So which forces are you supposed to add? FA, which is the force of the load, plus the total force divided by 2. So this one is FA plus FB over 2. The force at A plus the force at B, we divide by 2. That's our average force. So using this, we can be able to calculate our average force here. It will be FA, 4,000, the force at A, that's 4,000, plus the force at B, which is 4,600, divide by 2, that's average. So we are going to have the average force in this case. All right, so this is going to give us 4,300 Newton. All right, as our average force. So since we are given the velocity here, you can calculate the power because we are given the velocity of 2,2 meters per second. So with the velocity here of 2,2 meters per second, we can be able to calculate our power, because power from velocity is the force times velocity, and we're using the effective force, which is 4,300 times the velocity there, which is 2,2. So this is going to give us the power, and that is going to give us 9,460 watts, right? Which is the power. If you divide by 1,000, that's 9,46 kilowatts. So that is the idea of the question. They can give this question the way that is given this way. You have to be very, very careful, right? You have to be very, very careful. If I'm saying you have to be very, very careful, I know what I'm talking about. I know what I am talking about, because these questions, they are just confusing. Sometimes you don't know what is it that I'm supposed to consider. Read your question to understand. They are saying it's 15 meters, and 15 meters from this point here, it's simply halfway. It is simply what? It is simply halfway. It is simply halfway. So if it is halfway, what do you do if it is halfway? You consider the average force on that condition. Okay, this is it. We could have calculated this. Remember, I talked about this formula here. Okay, let me put it this way, because someone might say, what if I do not want to use this one for the average force? All right. Remember, I said previously from the introduction that we had that when you are given a certain distance and you have to consider calculating power, it's because the power is affected by the force. So the force is affected, or the force is affected because of what? Because there are two forces there. So this power, which was supposed to be taken as the total force times the velocity, the force here is affected by two things. One, the force of the load, which is the force at A, which I said this one, it does not change whether you move 2 meters or 3 meters. It is not affected. It remains as it is, which is the F at A, that is the force of the load. So it's The force at A, that is the force of the load, plus the force of the chain, in this case, which is the weight of the chain. These are the two things that gives us the total force. But what happens is that for this chain, its force is affected. Why? It is affected because of the concept that the chain is given its force per meter. 20 Newton per meter, it means it's affected per each meter, per each meter, like that. Each meter, each 1 meter, each 1 meter, each 1 meter, the force is affected. That's for the chain. So when you are given this, I said, instead, because you're given that it is 15 meters from the drum, meaning say from the drum, in this case, what is going to be the remaining distance? 30 minus 15 is 15. So there's no effect. So it's just going to remain as what? As 15. If you are given the top distance, remember, you use the top distance. But if you subtract 15 by 30 minus, it's just 15. 30 minus 15 is just 15. So this here, the weight of the chain is going, I said it is going to be given as the weight that you are given of the chain per meter, that one that you'll be given per meter, times the distance that you are given, which is S. And this distance here is not just the ordinary, the one that you are given from the original question. No, this is the top distance. You consider the top distance. I talked about this. So if you are to consider this, it means the force of the chain, which is the weight of the chain, was going to be given as what? Let's consider the weight of the chain first. So the weight of the chain, which is the force of the chain, was going to be the one. Remember, the force of the chain per meter is 20 Newton per meter. So it was going to be 20 Newton per meter, all right? 20 Newton per meter times the distance, which is 15 meters from the top. So if we multiply this, what are you going to get? 20 times 15 will be something like 300. So this will give us 300 Newton as the force of the chain from the 15 meters from the top distance. So this is what you're going to do now to calculate power. You're going to take that force of the chain, you come with it here because we need the total force here. And this total force is supposed to carry two things: the force of the load, which is the force at A, all right? Which is the force of the load, sorry. The force of the load here, which is the force at A. This is our load, which is 4,000. That one is fixed. It does not change. So we've got 4,000 for the load plus the force of the chain, which is the weight of the chain from the top distance. We got here 300 Newton as what? As the force of the chain, times the velocity now in meters per second, which is the velocity that we are given as what? 2,2 meters per second. Guys, we are going to obtain the same answer as that one. Let's see. All right, so let us just have our calculator here and see what you're gonna have. So this is 4,000. Let's just open a bracket. 4,000 plus 4,000, plus 300. 4,000 plus 300 like this times 2,2. So that will be 9,460. 9,460 watts. So this is your power, with which you can convert to kilowatts, just like the previous case where we obtained this. So as you can see, we are obtaining the same answer, just like the previous case. But just take a closer look. It depends with how you understand. But this one is the best because you might not see that the distance is in between, it's halfway. This average formula, the average force. The average force is when it is what? Halfway. The distance is halfway. So know where to use the formula and how to apply the formula. Guys, you must know this and try to revise more question papers. You understand how they ask these questions. Okay, sorry for that. This is too much. I want this part only here. All right, so on this part, they are saying here, a pulling force of 100 newtons, so given in this case, a pulling force which is of 100 Newton, is applied to an object on an incline of 25 degrees. So there is a pulling force there, the pulling, that is, you are taking this up, all right, to pull. Remember, there is to push and to pull. All right, let me present this way. So this is it here. We have got an object that is here, that is placed here. This is our object here. So if we want to pull this object up, we are taking it like this. This is to pull it up. We are pulling it up, going it up like that. That is to pull. When you take it like this, you are pushing it down, okay? Or when you are this side like this, you are pushing it up. But when you are this side, you are pulling. This side, you push, okay? These are two different things. So this one, it's a pulling force. So we are given Ft, the total force of 100 Newton. Or if, remember, when you're given a condition like to ignore any friction, it means this Ft is equal to the parallel component, which is our Fs. Okay? This is at 20 degrees. Is that so? 25 degrees, sorry. That's at 25 degrees here to the horizontal. In order for the object to move upwards at a constant velocity, calculate the mass of the object. All right, so what is going to be the mass of the object? Yes, you are going to have your perpendicular here, your M, your weight component, this and that. But what we know is that if there is no friction, these two, they are equal. I talked about this. Ft is equal to Fs. So taking advantage of Fs, because Fs represents a parallel component, which is the mg sine of theta from the weight sine of theta. Remember, weight sine of theta, that's Fs, whereby Fc is equal to weight cos of theta, the perpendicular component. All right. So here, remember, what we want is to calculate the mass of the object, the mass of the object. What is going to be the mass of the object, which is m? So it's either I'm going to make m the subject by just dividing by g sine of theta, divide by g sine of theta like this. So this will cancel. So it means the mass of this object is going to be the total force. What is the total force? 100, which is our parallel component, because they are equal. It also means there is 100 Newton here. So it's going to be the total force of 100 over the gravitational acceleration of 9,8 times the sine of theta, the sine of the angle that we are given of 25 degrees, right? Which is the one that you're going to see also here at this point. So this was going to give us the mass of the object. So you see, they just ask different questions to test you. Can you manipulate your formulas? So if you're someone who's doing science, also be used to your maths so that you can be able to manipulate your formulas in the way that you want it to be like. So your mass was going to be 24,1449, something like that, which is to 3 decimal place. That's going to be 24,145 in kilograms. Right, I talked about this rounding off of values on your calculator, that we can simply do this on our calculator here. That's 100 over 9,8. This is 9,8 times the sine of what? The sine of 25 degrees. We close the bracket. Make sure that your calculator is in degrees there on top. So this is going to give us this 24, this. So to round off to 3 decimal place, shift, you go to the setup, then you press the 6 there to fix your calculator to 3 decimal place, you press 3. So your answer is going to be 3 decimal places. You can see 24,145. So this is the one that you're having here. And you must be able to bring back your calculator to the normal mode. So it's shift, setup, you press the 8, back to the normal mode, then you press 2, your calculator is back to the normal mode. So you must be able to do also the vice versa. If you're under exam condition, be able to change back your calculator. But that's it, guys. We shall see more questions to come from Maths on African Motives till we meet again.